Why can animals go for long periods without eating, while humans have to eat every day? Look at lions and tigers, they can go hungry for a week after a single hunt, and still have the strength to hunt again after that week. But compared to them, humans' ability to withstand hunger is clearly lacking. If we went hungry for a week, let alone hunting, we'd probably be too weak to even lift a finger. So why can't humans be like animals, eating just one meal a week, and have that meal last for the whole week? Wouldn't it be great to use all the time saved from eating to do other more meaningful things? The reason is that humans and animals use their stored body fat differently when they're hungry. It's easy for humans to store fat, but when it comes to burning that fat, our bodies are pretty stingy. It's kind of like a bank, it's easy to deposit money, but when you want to withdraw it, things get a bit tricky. Under normal circumstances, the human body gets its energy from glucose. Once the glucose is used up, it starts to consume glycogen. At this point, fat, as the ultimate reserve, remains untouched. But if you keep starving yourself for another 2.5 days, your body will finally start burning fat. However, by this point, you've already been hungry for a while, so your genes will assume that the external environment has worsened and food is scarce. As a result, your body will switch to energy-saving mode, trying to help you survive a bit longer by reducing energy expenditure. And the most effective way to reduce energy expenditure is to lose muscle. In other words, at this point, the protein in your body is also being broken down to provide energy. When protein is broken down, your cells can no longer maintain normal physiological functions. If you continue to starve, even if there is still a lot of fat left in your body that hasn't been used up, you won't be able to hold on any longer. It's like dying before you've spent all your money. As for lions and tigers, when they are starving, although their proteins are also broken down, they can adjust their bodies to a mode where only fat is used for energy. It's as if it's easy for them to both save and withdraw money from the bank their fat provides energy smoothly. Therefore, the amino acids produced from protein breakdown don't need to be used for energy, but are instead reassembled into new proteins. You could simply think of it as lions and tigers. When starving, will take bricks from one wall to repair another, while humans, when starving, just burn the planks they take down as firewood. Naturally, this means they can endure hunger much longer than humans. However, the human body is extremely stingy when it comes to burning fat, yet has an almost obsessive compulsion to store it. Any surplus energy, no matter how little, will be converted into fat for storage. Normally, the carbohydrates we eat are converted into glucose. Fats are broken down into glycerol and fatty acids, and proteins are turned into amino acids. If the cells can't use up these nutrients right away, the glucose will be compressed into glycogen and stored in a zip format, which is glycogen. But if there's still an excess of nutrients and the glycogen has already filled up the storage space, what happens then? All the extra glucose, glycerol, fatty acids, and amino acids will be sent straight to the liver, where they're all compressed into fat for storage. In other words, no matter what you're called when you came in, when you leave, you only have one name: fat. So in our daily lives, we should try not to consume excess nutrients. If you take in too much fat, it can affect the activity of your sebaceous glands, causing them to secrete more oil, which makes your skin more prone to becoming oily. As for why our genes are so obsessed with storing fat, the truth is that humans have only been able to eat their fill in recent decades. Hundreds of thousands of years ago, people constantly alternated between being full and hungry, always living with anxiety about energy scarcity. So our genes prioritize retaining easily stored fat, and when it comes to using that fat, they are as stingy as possible. After all, our genes don't know how long food scarcity might last, so they use fat as sparingly as possible. And this entire mechanism has continued all the way to the present. It is precisely because of this calorie hoarding trait in human genes that we were able to survive one mass extinction after another and ultimately rise step by step to dominate the Earth.